Okay, there were several requests for free response question 2 in your AP packet, and this one was maybe more of a reading question than a math question because it looks really scary. And if we break it down, the function that you're given is giving you temperature in terms of H, which is T is the temperature in degrees Fahrenheit, H is the number of hours from midnight. So T is my Y value here, and then H is my variable, just like my X variable. A and B are constants, we just don't know what they are yet. So if you really focus in on that equation right there, we got to start with what does that mean, and how can I work with that? So if you take a look at what I did, I came up with 2 coordinate points that you're given, although they don't give them to you as coordinate points, from the sentence when you get to part A. The initial temperature at midnight was negative 15 degrees Fahrenheit. So that's giving me this 0 and negative 15. Hour measurement, so at midnight, that means, remember, our H is the number of hours from midnight. So H value is 0, and then negative 15 is my temperature. Plugging in here, negative 15 and 0 over here. And then the same thing, the second sentence says at noon of New Year's Day, so that's 12 hours from midnight. There's my 12. The temperature was 5 degrees Fahrenheit. So there's my 5, temperature, and 12 went in over here. And then the first one, obviously, you've got cosine of 0, because pi times 0 divided by 12 is 0. And then the second one, I end up with just 1 pi. Simplifying those equations, I end up with cosine of 0 is just 1. So this entire part right here becomes 1. So I have negative b times 1. And then the next one, cosine of pi, is negative 1. So I get negative b times negative 1 here is a positive b. And that's what I've got right here. And then from there, it's solving a system of equations, looking for A and B. I did elimination, and you guys have done that a million times. I think it was just a matter of getting to that point. And like I said, very little calculus in this question at all. That's really a pre-calculus question, interpreting the information given. The calculus is coming. Let's skip ahead to part D, which is the other one that you could have done when I gave out this packet. There's a keyword there. It says find an expression for the rate that the temperature is changing with respect to H. So rate, we're looking for a derivative. And that's the first thing that I noted. And so I did go ahead and rewrite my equation. This equation is my new equation after I put in the A and B values that I got. So because they had you solve that, they wanted you to use the new equation. Again, if your A and B were wrong and you correctly went from your equation to the next line, you would get full credit for that on the AP test. So that's kind of nice. Even if you weren't able to solve part A, it would be to your best benefit to go ahead and make up an answer, so to speak, for A and write it down and make it look like you're confident that A equals whatever and B equals whatever, and then go ahead and use that. Taking the derivative, I've got, let's see, derivative with respect to H, derivative of a constant is 0, and then negative 10 is a multiple out front, derivative of cosine, negative sine, pi h times 12, or pi 8 times h divided by 12, and then I've got chain rule. So basically right here I've got u equals pi times h divided by 12. Cosine u became negative sine u, and u prime is pi over 12, and then I'm taking derivative with respect to h, so I don't have to multiply by dh, dh, because that would just be 1. So, sorry, that's a little sloppy there. Let's see if I can fix that. So pi times h divided by 12, and then u prime we said was just pi over 12. And that's this part right here. So there's my chain rule, and I went ahead and simplified that. You would have gotten full credit, though, if you had left it just like that. I guess we can get rid of the 0. While we're on this question, we should go ahead and take a second and take a look at part C, because I'm seeing the word or the phrasing use the trapezoidal rule. And that's something that we have just recently done in class. So let's take a look. Trapezoidal rule with 4 equal subdivisions to estimate. And this is almost exactly like the worksheet that you have that you're currently working on, area approximations. So we're interpreting the integral from 6 to 8 of my function t of h dh. This variable just has to match that variable. Remember, this is really my heights of my rectangles, and this is really my widths. And my integral symbol is, of course, summing up all of the areas of my rectangles, or it could be trapezoids, and giving me the exact area. So this is directly interpreted as area under the curve of some function, in this case, my temperature function. So this does give me the exact answer, but since I don't yet know how to calculate an integral, I'm going to use my estimation methods. And in this case, in particular, we're using the trapezoidal rule. So trapezoidal rule, remember your area of a trapezoid is 1/2, or I don't think I wrote it that way. Let's do it this way. Base 1, so this is formula. Oops. Come on. Formula, we've got base 1 plus base 2 divided by 2 times height. And your bases of your trapezoids are your parallel sides. So in terms of our picture that we've been looking at, where we've got a trapezoid here, and then we might have a trapezoid here. Bad picture, but you get the idea. Your bases are these vertical sides. So those are your functional values. So if we're going to go ahead and do this, every time I see a B, that's going to be some functional value. And then my height is really my width of my rectangle or trapezoids, which are going to be, in this case, since I want 4 equal subdivisions, I'm going from 8 to 6. So let's just make this 6. And let's sketch in 2 more. So I want 2 more. And again, these are some sort of trapezoids. So I want to do 4 equal subdivisions. I want to go from 6 to 8. 8 minus 6 divided by 2 gives me 2. Whoops. Divided by... Oh, where'd it go? Okay, well, I just lost what I had there. Technical difficulties. But what I was going to show you, that's okay. What I was going to show you is that my interval was 8 minus, my interval's from 6 to 8. So if I find the difference there, that means I really have an interval of 2. I'm dividing into 4 equal subdivisions. So each interval has a width of 1/2. And if I've got that figured out, then I can use that for my height. So what I'm going to do is just give you a quick setup. And remember, I've got function. I'm going to put the formula right back up here. So area of a trapezoid is base 1 plus base 2 divided by 2, and then times my height, which is my width, and that's what we were getting at over here. So what's that going to look like when it's all said and done? Giving you a setup here. Area is going to be... I'm going to use t for my function. T of 6 plus t of the next spot, if I'm going with an interval of 1/2, is going to be 6.5. Divided by 2 times the height of 1/2. And this is a calculator question. Number 2 would be a calculator question, so I would totally just type this in the calculator. Plus my second trapezoid is going to be my temperature value at 6.5, averaged with my temperature value at 7. So add them up, divide by 2, times my height of my trapezoid is the width, 1/2. And I've only got 4 of them to do, so let's go ahead and keep going. Plus T of, you've probably got the idea here, temperature at 7 plus temperature at 7.5 averaged together, and my final trapezoid is going to have a base of 7.5 and a base of 8 average to bases, and then multiply by 1/2. So this is what you would be doing in your calculator. This is a case where I would definitely put that function in your y equals, and then in your calculator, what you could do is you could literally just call it up. So instead of t, it would look like this in my calculator, y1 of, because you are not going to want to type that function into your calculator every single time, y1 of 6 plus y1 of 6.5. So your t's are just going to become y1s. So give that a try, but that would give you your trapezoidal estimate.